Good afternoon. Today we're going to talk about the distance and midpoint formulas. You may have studied these a little bit in Algebra 1, but we're going to study them a little further in depth here in geometry. So for our bell work today, I want you to hit pause and I want you to answer the next 3 questions and then hit resume when you are finished. All right, let's chat. What are the 3 undefined terms in geometry? Those 3 undefined terms are point, line, and plane. Number 2, what represents the intersection of the wall and the ceiling? So if you will look at a wall and look at the ceiling, they form a line. And then we want to sketch opposite rays CA and CB. So if you look at what they have in common, they both have a common endpoint. So if we say, all right, here's point C, we can put point A over here, and we can put point B over here. So what happens is ray CA starts here and goes this way. And if we look at ray CB starts here and goes this way. And because they have that endpoint in common, those are considered to be opposite rays. All right, so true or false? The intersection of line EF and plane JHK is HI. So if we look at line EF is right here. And if I look at plane JHK, it's this gray plane right here. And those two intersect right here at point G. Now, so they intersect in a point, therefore they do not intersect in a line, which would make this question false. Number 2. The intersection of plane EFG and plane JGI is point G. If you look at where these 2 planes intersect, those 2 planes intersect right here, and that is line HI, and so they don't intersect in a point, so number 2 is also false. All right, so we're going to talk about distance and midpoint. So I want you to hit pause and I want you to work through problems A through C on your paper. And when you are done, go ahead and hit resume and we will talk. All right, welcome back. We're going to plot the point A, which is 3, 4, which is right here. And we're going to plot the point B, which is the point -5, 2, and we're going to find the point that's in the middle of line segment AB. So we could do that a lot of different ways. We could just count squares. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, not 9, just 8. We have 8 squares that go this way. So if I count over 4, 1, 2, 3, 4, I'm going to approximate the middle to be right here. I can also look at this vertical distance. That vertical distance is 3 units, and that vertical distance is 3 units as well. So I'm going to conclude that the midpoint is approximately the point -1, 1. And it says to label that point M. Another way I could think about this is just a shortcut that we call ME. And ME stands for endpoint, midpoint, endpoint. So if I know my 2 endpoints, which I do, 3 and 4, -5 and -2, this is going to be the number in the middle of these numbers. So if you remember, middle means average. So if I take 3 plus a -5 and I divide that by 2, this becomes -2 over 2, which is -1. And if I take 4 plus a -2 and also divide that by 2, I get 2 divided by 2, which is 1. So that's a way that we could also mathematically calculate the midpoint, and we call that ME. The actual formula for the midpoint is x1 plus x2 divided by 2, which is simply the average of the x values. And over here, we have y1 plus y2 divided by 2, which is the average of the y values. This is the official mathematical definition of the midpoint if you have 2 endpoints, A, B, with coordinates x1, y1, and x2, y2. Question D says, how does the process change if 3, 4 is the endpoint and -5, 2 is a midpoint? So I'm quickly going to sketch these on my graph. So here's point A, and point B is 2, 3, 4. Okay, and so what happens now is, if we look at this graph, A is an endpoint, but B is actually the midpoint. So that means if this graph were to continue off the paper, there would be another endpoint way down here that would serve as my second endpoint. This is where the process of ME comes in very handy. So remember, endpoint, midpoint, endpoint. So if I look at the information given in the problem, I have point A, which is an endpoint. So I'm going to write that right here as an endpoint. Point B is a midpoint. So in ME, M stands for midpoint. So I'm going to put -5, -2. Ultimately, math is a study of patterns. So what we're going to look at is we're going to look in the pattern of these numbers. So if I look at what's happening to my x-coordinates as I go from here to here, and I go from 3 to -5, if you think of a number line, and here's 3 and here's -5, I'm going down. I'm getting smaller. Okay, so to go from 3 to -5, I actually subtracted a value of 8. So what happens is if I go 8 more units over here, that is going to be the x-coordinate of my endpoint. So if I take -5 and I subtract 8, I get -13. On the other side, we have y. So I have to think, okay, I'm going from 4 to -2. Here's 4 on a number line. Here's -2 on a number line. So again, I'm getting smaller. And to go from 4 to -2, I subtracted 6. So here, I'm going to start at -2. I'm going to subtract 6. And -2 minus 6 is -8. So that means there's some point down here with the coordinates -13, -8, and that would be my other midpoint. And if you think about your graph, this is in quadrant 3 where we go left and we go down. So having a negative value and another negative value would put that point in the right quadrant. All right, so the distance formula. We're going to use the same 2 points. So we have point A at 3, 4. And we have point B at -5, -2. And we're going to connect those. And this time we want distance. So if we think of the word distance, we're actually going to associate that with the word length. Okay, how far is it from A to B? Now, we can't exactly count squares because we're on the diagonal, but we can go ahead and take this and we can triangulate it. So I can take and drop straight down from point A and straight over from point B, and what that makes is a right triangle. So now that I have my horizontal and vertical distance, you could technically count 1, 2, 3, 4, 5, 6, and this length is 6, and 1, 2, 3, 4, 5, 6, 7, 8, and this side is 8. And we could actually come over here and we could do the Pythagorean theorem. Okay, and you guys learned the Pythagorean theorem in junior high. You learned it as a squared plus b squared equals c squared. I also like to think of it as leg squared plus leg squared equals your hypotenuse squared. So if I take one of my legs, which is 6, and I have 6 squared, and I add that to 8 squared, I'm going to get the length of AB squared. If you get your calculator out, 6 squared is 36, and 8 squared is 64. 36 plus 64 is 100, and that equals the side length AB squared. To undo a square, you're going to come in here, and you're going to take the square root, which tells me that the length of side AB is 10 units. So where does the Pythagorean theorem really come from? The Pythagorean theorem really is the distance formula. And the distance formula says, hey, we're going to take x2 and we're going to subtract x1. All that is your horizontal length of your triangle. So that would be this length. And right here we have y1 minus or y2 minus y1, which is really, oh, spelled that wrong, vertical length. Still spelled it wrong. Okay, that's your vertical length. Fix that real fast. Vertical vertical length. And that's this length right here. And that would allow us to find this distance AB right here, which would be the hypotenuse of your right triangle. So the x2 minus x1 and the y2 minus y1 are really basically just the length of the legs of your right triangle. And this is a picture that goes with it. So again, here is x2 minus x1, your horizontal distance. Here is y2 minus y1, your vertical distance, and that just basically gives you the lengths of the sides of your right triangle. So just some practice problems that are mixed in review. This one says find the midpoint if the endpoints of a segment are -6, 4, and 1, 9. You could sketch a picture if you want, but that's not going to be required. You see the word midpoint and endpoint, so that should really just draw you to ME. And I will also show you how to use the mathematical formula. It says our endpoints, so both of these are an endpoint right here and here. So we have -6 and 4, and we have 1, and we have 9. When we come to find the midpoint, remember the midpoint is just the average. So this is where you actually apply the formula. So -6 plus 1 divided by 2. -6 plus 1 is -5 divided by 2. And quite frankly, you could just leave that as a fraction, or you could put that in the calculator and get a decimal. Then your y-coordinate is going to be the average of your y's. 4 plus 9 divided by 2. If you take 4 plus 9, you get 13. And again, I just assume you leave that as a fraction. If you want to put it in the calculator, again, technically that's okay because these are halves and end up as 6.5. All right. This example number 2 says to find the missing endpoint if -6, 4 is an endpoint and 1, 9 is a midpoint. So again, we see the words midpoint and endpoint, which is just going to draw us to ME. We have to get everything put in the correct place. So it says find the missing endpoint if -6, 4 is an endpoint. So that tells me that -6, 4 is one endpoint. And they say -1, 9 is actually your midpoint. So that's going to be M in the ME. So this is 1, -9. And ultimately, we need to come down here and we need to find the other endpoint. So we're going to look at patterns. If I go from -6 to +1, and if you need to think about that on a number line, if you go from -6 to +1, we're getting bigger. So we're adding, and we're going to add 7 because that's the distance between the two numbers. So if we add 7 to go from -6 to 1, we're going to add 7 again. So 7 plus 1 is 8, and that is the x-coordinate of my endpoint. Over here on the right-hand side, we're going to go from 4 to -9. So if you think about your number line, and some of you will, the number line helps, others don't need the number line. The distance between 4 and -9, if you subtract those two numbers, the distance is 13, and we're going down because we went to the left. So here we subtracted 13 to go from 4 to -9. So I'm going to subtract 13 again. And if I take -9 minus 13, -22, I get -21. So this endpoint has a coordinate, y-coordinate of -21. All right, excellent. So now example 3 says find the exact length. So the fact that you see the word length right here in your problem really just has you going to the distance formula. Okay, and it says find the length of BC with midpoint A 2, 5 and one endpoint B -4, 8. So what's going to happen is I have an endpoint and a midpoint, and I really need two endpoints to use the distance formula. So I'm going to start out by using ME. And ME says, okay, I have a midpoint that's at 2, 5. So I have a midpoint at 2, 5. And here I have one endpoint at -4, 8. So I'm going to think about how do I go from -4 to 2. I'm getting bigger, and I'm getting bigger because I added 6. So from here to here, I'm also going to add 6. 2 plus 6 is 8. On my y-coordinates, if I start at 8 and I go to 5, I'm going down, I'm getting smaller, and I'm getting smaller by 3. So here, I'm also getting smaller by 3, so I have 5 minus 3, which is 2. So now I have my 2 endpoints. So using the distance formula, your distance, you got to subtract the x-coordinates. So I'm going to take the numbers in red, and I'm going to subtract the x-coordinates. -4 minus 8 squared. And I'm going to add that to the difference of the y-coordinates. So now I'm going to take and subtract the y-coordinates, 8 minus 2 squared. And I'm going to do some quick math here. -4 minus 8 is -12. You're going to end up squaring that. 8 minus 2 is 6. 12 squared, -12 squared is 144. And 6 squared is 36, which is going to give me the square root. 144 plus 36 is 180. So now I have to think about breaking that down into numbers that I can take the square root of. So if I do that, I can take this and break 180 down into 9 times 20. The square root of 9 is 3. When I look at 20, 20 is actually 4 times 5. So I think of 4, and I can take the square root of 4, which is 2. And so out in front, I have 6, and inside I have 5. So your answer is going to be 6 square root of 5. If they ask for an approximate value, you can actually put that in the calculator. And if you have a multi-view calculator, it will actually simplify that square root for you. However, in honors, you don't get a calculator on your test, so you've got to make sure that you can simplify those radicals. In regular, you will actually have a calculator, and you can put this last part right here all in your calculator. So if you put the square root of 180 in your calculator, you will get 6 square root of 5.